Hey, my name is Mradul Ghelot, and today we will be understanding shortest job first CPU scheduling algorithm. We will understand its both preemptive and non-preemptive nature. So first start with what is CPU scheduling and why it is needed. So the definition says CPU scheduling is the process of determining which process in the ready queue is to be allocated to the CPU. The purpose is the efficient utilization of CPU and managing process execution. The importance that it ensures maximum CPU utilization and system responsiveness. So there are two types of CPU scheduling algorithms, preemptive and non-preemptive, and can be further classified according to priority. So preemptive scheduling algorithms allows a process to be interrupted during its execution, and non-preemptive scheduling algorithms say that once a process starts executing, it cannot be stopped until its completion. And static priority is assigned before execution, and dynamic priority can change during runtime. So let's look at shortest job first CPU scheduling algorithm. So as the name suggests, shortest job first means it selects the process with the smallest execution time or burst time. The objective is to minimize average waiting time. It has two types, non-preemptive and preemptive. Preemptive is also known as shortest remaining time first. So first let us look at non-preemptive SJF scheduling algorithm. The working is very simple. The process with the shortest burst time is selected next. And once a process starts execution, it runs until its completion. And we will create Gantt chart and do calculations to find waiting time, turnaround time, average of waiting time, and average turnaround time. So let's understand it with an example. We are given four processes P1, P2, P3, and P4, and their arrival time 0, 2, 4, 6, and their burst time 6, 8, 7, 3. So first of all, let's create Gantt chart. So at time interval 0, the process P1 arrives in ready queue. So at time 0, P1 arrives in the ready queue and it will be allocated CPU. And it will execute until its completion at time 6 seconds. Next, after 6 seconds of its execution, we have 2, 4, and 6 arrival time. So process P2, P3, and P4, all three are available in the ready queue. So now which process is be selected? It depends on burst time. The minimum burst time, P4 has the minimum burst time. So P4 will get the CPU and will execute for 3 seconds. So we will be getting 9 here. And after that, we have P2 and P3 remaining. So P3 is smaller burst time. So P3 will get the CPU and will execute for 7 unit of times. Mean it will execute from 9 to 16. Now at the end, we have only P2 process left, which will get the CPU and will execute for 8 unit of time, means from 16 to 24. Okay, now let's put all this data in our table. So these are four processes. Arrival time is 0246 and burst time is 6873 and completion time of process P1 is 6 unit times, P2 is 24 unit times, P3 is 16 unit times, and P4 is 9 unit times. So we got our turnaround time, which is the difference of completion time minus arrival time, and we got our waiting time, which is the difference of turnaround time and burst time. And here we have calculated our average turnaround time and average waiting time. Now let's understand it with an practical implementation with code written in C++. So this is SJF non-preemptive. We have four number of processes Arrival time and bus time is 06, 28, 47 and 63. So this is table and this is our average waiting time which is 4.75. We can verify it using table and average turnaround time is 10.75. Okay. So this is the sample question we have solved just now, and so far we have studied. Now we will look at preemptive shortest job for scheduling algorithm. The preemptive works differently from the non-preemptive. Its working is little bit confusing, but it's easy. So at every scheduling decision point, the process with the shortest remaining time is to be selected. And suppose if a new process arises with the shortest remaining time, it preempts the current process execution. So let us understand it with an example. So this is the sample question given. Let's start by creating a Gantt chart. So at time 0, we have only process P1 in the ready queue. So P1 will get the CPU and it will, suppose it will execute for 1 second. Now we have process P2 in our ready queue, P1 and P2. And P1 has already executed for 1 second, so remaining time is 7 units. And P2, it's 4 units. So P2 has smaller. So P2 will get the CPU. It will preempt the P1 process and it will get the CPU. Now after executing for 1 second, at 2 seconds, process P3 arrives, but it has greater burst time. P1 has 7, P2 remaining is 3, and P3 is 9. So P3 cannot preempt P2. Similarly, if P4 will come at 3 seconds, it will be having 5 burst time. At that time, P2 will be remaining with only 2 burst time. So upcoming processes cannot preempt P2. So P2 will complete its execution. Instead of reaching to working till 2 seconds, it will complete 4. So it will execute from 1 to 5. And after that, we have three processes in the ready queue, P1, P3 and P4. P1 remaining time is 7 units, P3 is 9 and P4 is 5. So P4 has the smallest. So P4 will get the CPU and P4 will execute for 5 unit of time, means up to 10 seconds. And after that, we have P3 and P1 remaining in our ready queue. P1 has execution remaining time of 7 seconds. So P1 will get the CPU. Let me create another P1. So again, P1 will get the CPU and it will complete its remaining 7-second execution. So 10 plus 7 is 17. And at the end, P3 will get the CPU and it will execute for 9 seconds. So at 26, our execution stops. Let's create table. So arrival time of processes is 0, 1, 2, 3 and burst time is 8, 4, 9, 5 and completion time for P1 process is 17 and for P2 it's 5, for P3 it's 26 and for P4 it's 10. So after calculating all this, we got average of turnaround time as 13 units and waiting as 6.5. Let's again confirm it by running an sample example. So we have four processes. Arrival time and bus time is 08, 14, 29, 35. So we got average waiting time as 6.5 and turnaround is 13. We can verify using our table. So now let's look at the advantages of shortest job first scheduling algorithm. The optimal, it ensures that the average waiting time should be minimum for a set of processes. Means it gives optimal average waiting time. It is efficient for batch processing. Batch processes ideal for systems where all jobs are available simultaneously. and it has improved throughput by executing shorter jobs first. More processes are completed in less time. Now, let's look at disadvantages of shortest job first scheduling. First is starvation. Longer processes may suffer indefinite postponements if shorter processes keep arriving. So, suppose if a longer process have a bus time of 50 seconds, and suppose smaller process keep coming, so it gets preempted again and again, it won't get CPU, so it will face starvation. Second, it is difficult to predict bus time. This requires a accurate estimation of the bus time, which is not always feasible. It is not suitable for interactive systems. Due to its non-preemptive nature, it may not provide the desired responsiveness. Now let's compare this algorithm with other algorithm. The first come first serve algorithm is simple but can lead to high average waiting time, while SJF gives better average waiting time, but it may cause starvation. Now let's look at round robin versus SJF. Round robin gives fair time sharing but have higher average waiting time, while SJF is efficient but it is not fair to longer processes. Now, many of people have confusion between SJF and EDF. EDF means earliest deadline first. It's an algorithm in real-time operating systems. So SJF focuses on minimizing average waiting time, but it does not focus on deadline, and it may not be suitable for real-time systems. And EDF prioritizes tasks with the earliest deadlines and optimal for real-time systems where meeting deadline is critical. So comparison is EDF ensures deadline adherence, making it more suitable for real-time applications compared to SJF. Let us understand it with an example. Suppose you are in a shopping mall and fire alarm doesn't uh, doesn't ring at a time and water sprinklers don't start. So this is a practical example where earliest deadline first algorithm plays an important role. It ensures that the task meets its deadline. And this is a practical practice question I have included. You can practice it on your own. This question came in GATE examination also. So this is practical code implementation for SJF non-preemptive. I have shown you the execution of code, and you can create your own code by following this algorithm. And this is practical code implementation for SJF preemptive in nature. So thank you.